Welcome to today's lesson. Today we are going to go through Form 3 Chemistry under a topic Organic Chemistry. And the flowchart we have reads, study the following reaction scheme and answer the questions that follow. When analyzing the flowchart, you need to look at the direction of the arrows. And in this case, you realize we have concentrated sulfuric acid together with ethanol going through step 1 under the condition of the given temperature to form the colorless gas A. Then we burn the colorless gas A in air to give us gas D and liquid E. Then of course gas A undergoes step 3 to form product B, and the same colorless gas A goes through step 2 to produce ethane gas in that particular order. So we are going to begin from concentrated sulfuric acid and ethanol, and we know if you have an alkanol and concentrated sulfuric acid, that is the part which examines the preparation of alkenes. In this case, we have ethanol, which is C2H5OH in the presence of concentrated sulfuric acid. Remember, concentrated sulfuric acid is a dehydrating agent, and concentrated sulfuric acid will remove water elements from ethanol to give us colorless gas A. In this case, if concentrated sulfuric 6 acid removes water, we are going to have the formula of the water, which is H2O, meaning the OH requires only one hydrogen from the hydrocarbon part. So if we remove one hydrogen from here, we are going to remain with C2H5. Then the one hydrogen will combine with OH to give us water. So we are going to have C2H4, and in this case now we are going to get C2H4, which is our colorless gas. So we have C2H4, which is ethene gas. Then ethene gas is burnt in air to produce gas D and liquid E. And anytime you are burning an organic compound, expect only two products, that is carbon 4 oxide and water. So we are going to have C2H4, this is ethene gas, plus oxygen, and this one is going to give us water and carbon 4 oxide. We have carbon 4 oxide gas plus water. In this case, water is a liquid and carbon 4 oxide is a gas, and therefore gas D is carbon 4 oxide and liquid E is water. So we can still answer this question straight away. We have gas D as carbon 4 oxide, then liquid E is water. Then from this particular point here, we are going to have colorless gas A undergoing step 2 to give us ethane, and the formula of ethane is C2H6. If you look at C2H6 and C2H4, you realize we have two carbon atoms, but the hydrogen atoms have increased by 2, meaning we have added hydrogen in step 2, and the process where hydrogen is added is known as hydrogenation process. The last point where we are supposed to go is now from colorless gas A through step 3 to product B. If we have C2, let me draw the structure this way. Then we have hydrogen. We have 4 hydrogens like this, and we are adding hydrogen chloride. This one is where we have hydrogen chloride, sorry. So if we are adding hydrogen chloride to ethene gas, we have hydrogen chloride this way. So this hydrogen chloride will break the double bond such that we have chlorine coming here, and this hydrogen attaches itself there. And in this case, now we have a single bond. We are going to talk about alkanes. In this case, now we can say this is 1-chloroethane, or simply what we call chloroethane. So let us now go through these questions. Name colorless gas A. We have said the colorless gas A is ethene gas, C2H4. Product B is chloroethane, or simply 1. In carbon number 1 we have chlorine. Since we have 2 carbon atoms in the longest continuous chain, we are going to have 1-chloroethane. We can simply say 1-chloroethane. Once the double bond has been broken, we are going to have now the one that has a single bond, which belongs to the class of alkanes. So we have a colorless gas A, we have product B, we have gas D, and lastly we have liquid E, which is water. Let us go to part B of the question. B says, write balanced equations for each of the reactions forming the products in A above. So if I can wrap this part, here, we are going now to do part B of the question by writing all the equations forming the products that we have already mentioned above. In this case now, we have the formation of the colorless gas A from ethanol and concentrated sulfuric acid. So we are going to have C2H5OH. This is a liquid. In the presence of concentrated sulfuric acid, concentrated sulfuric acid being a dehydrating agent, it removes water from here. So we need 1 hydrogen from the hydrocarbon part to form water with OH. Then we remain with C2H4, which is a gas, plus of course water, which is a liquid. And if you look at that particular equation, it is automatically balanced. So we have written an equation for the formation of the colorless gas A, which is ethene gas. This is an alkene. Then now, let us do another chemical equation for the formation of gas D and liquid E. The two are formed from the combustion or the burning of colorless gas A. So we are going to have C2H4, which is a gas, plus oxygen, and this one is going to give us automatically carbon 4 oxide and water. Water is a liquid, carbon 4 oxide is a gas. And now we balance the two equations. So for us to balance Carbons, we have 2, so we have to write 2 here so that carbon becomes 2. Then hydrogens are 4. The other side we have 2, so we write 2 here so that we balance the hydrogens. Now oxygen, we have 2 times 2, which is 4. Then 1 times 2, that is 2, that is already 6. We write 3 behind oxygen so that we can balance the oxygen atoms. So far we have done the equation for the gas D and liquid E. Next we are going to do the one that is forming ethane gas. So we are going to take C2H4, which is a gas. We add hydrogen, and this one is going to have, if we add the 2 hydrogens here, we are going to have C2H6, and the equation is automatically balanced. So the last part that we are going to do, it is the part that leads to the formation of product B. So I can remove this part here so that we look at that. I can remove this part so that we can have a look at how product B is formed. And product B is formed from ethene gas. We add the hydrogen chloride gas, and this one is going to, if this one hydrogen comes here, we are going to have C2H5Cl, and by so doing we have done that particular part, and this is product B, which is chloroethane, which is 1 chloroethane. I think we are through with part B. Then now let us look at part C. Part C of the question: name the type of reactions taking place in step 1 and step 2. The type of reaction taking place in step 1 and step 2. So step 1 is where we are adding we are dehydrating ethanol using concentrated sulfuric acid to form ethane gas, and the process here is dehydration. Then of course in step 2, where we are adding hydrogen, this is an addition reaction, but specifically this is hydrogenation, since we are adding hydrogen to that colorless gas. We have that was part C. Then of course now part D. Let me remove this part again. Let me remove this part. We look at part D, and part D of the question says part D says, state the importance of the reaction taking place in step 2. State the importance of the reaction taking place in step 2. Step 2 is hydrogenation, and hydrogenation is used in the manufacture of margarine or simply hardening of oils to fats. So we can say used in the manufacture of margarine. Used in the manufacture of margarine. That brings us to the end of this particular flowchart. In case you have a question that you'd like us to clarify, you can kindly interact with us in the comment section, and we shall be glad to address your concerns accordingly. And in case you have just come across this channel for the first time, kindly click the subscribe button so that anytime we do a video like this, you'll automatically be notified.